In this video, we are going to cover three topics: handler services and repository pattern, middlewares, and request context. Initially, the plan was to cover each topic in different videos. So this was supposed to be three videos, but since these three topics are so closely related with each other, in fact, pretty much all the topics are closely related to each other since we are talking about backends here, but I cannot go ahead and make a 100 hours video, right? So in this case, these are very closely related to each other, and it'll be easier to explain all three of them in the same context instead of repeating the same thing again and again in different videos. And that's the reason we are going to cover all three of the topics in this same video. Now let's talk about handlers, services, and repositories. I know that I have talked about this topic in different videos. I have mentioned it. In fact, I have even explained it a little bit in other videos. So it might sound a little bit repetitive, but I have never officially covered this topic. So this is the time that we can do that. Okay. So let's start with client and server. We have our client here and we have, say, server here. Okay, this is our client server, and we communicate with each other over HTTP. Now, when a client sends a request, it reaches our server. So the moment it reaches our server and until the moment it receives a response, there are a lot of things happening in the server, and we call that a request lifecycle. We already talked about the request lifecycle external to the server, like what happens at this point, the sending the request and sending the response. But we have not covered the request lifecycle inside the server. What happens inside the server throughout the lifecycle of the request? So let's cover that. What happens now? The request reaches here, and we have our entry point, the entry point of the server, the entry. The moment our operating system forwards that particular HTTP request to the particular port, it can be 3000, it can be 4000, any port that your server is running, your operating system forwards that request to your server, and the request reaches your server. That is the entry point of your request. Now what happens? Your server must be doing some kind of listen on some particular port, and that's how it gets the request. At the start of the request, what happens? We have routing. After the request reaches our server entry point, we have routing mechanisms. We have different routes. For example, users, then we have users /123, we have dynamic routes, and etc. We have already talked about routing and all. It reaches our routing algorithm, and depending on the routing algorithm, we map that request to a particular handler. Handler is basically any function that we have predefined that is supposed to handle the request of that API. We have mapped some kind of function for this as a handler for this route. Now we have the concept of handlers or controllers, services, and repositories. And why do we have three separate components? Why don't we only have a single handler which does all the stuff? And the thing is, we can have that. There is no requirement that we have to separate out the responsibilities into three different components. There is no hard requirement. It is just a design pattern so that your code base is scalable, it is more maintainable, and it is easier to add features, and it is easier to debug things, right? Now let's see what are the responsibilities of these three components. The first level, once we get the request here from the routing algorithm, it reaches the handler or the controller. So we have here handler / controller. Okay, what is the responsibility of this? We get the request, and in pretty much all the servers, it does not matter, you're dealing with Golang or Node.js or Python. Those are the three languages that I have personally used, so I'm not aware how the pattern works in other languages, but I'm pretty sure this is an established pattern that in each handler you will receive at least two objects or two variables, depending on what programming language that you are using, you'll receive two objects or two variables. One is the request object, one is the response object, and the handler can take out values from that HTTP request from the request object, and it can send responses and it can modify response headers, etc., using the response object. This is why we get these two objects, and we don't necessarily add these two objects ourselves. The runtime, the programming language that you are using. If you are using Go, then Go provides these two objects to you by default on your handler's parameters. And similarly for Node.js also, if you're using Express or anything like that, you will get this request and response provided to you. You don't have to add them. You will get them for each request. Now what happens? At the entry point of handler, what is the first thing that comes to your mind? That we need to find what is the request about. We already know that what is this API supposed to do, because this API was routed to a particular route above here, and we got this in this particular handler. So we know that what particular API that this client is trying to call. We already have that part of the information. Now we want to take out different values so that we can process the request and send a response accordingly. We can do different database operations. We can do external logics. We can do external API calls. We can do, we can send emails. We can send notifications. We can do a lot of things inside our processing logic, and we have to send a response, or we don't have to send a response depending on what kind of request it is. If it is a delete request, then our RESTful standards say that you have to send a response code of 204 no content with an empty response body. And depending on that, we can decide what response. Now, at the entry point, what is the first thing that comes to your mind? That you have to take out the data from this request object. That is the first responsibility of a handler, of a controller. So this is what you have to keep in mind. Again, this is not a necessary requirement. You can do everything in your handler/controller, but in a typical backend architecture, this is how we structure it to make it more scalable. Now, in the first entry point of your controller or a handler, your responsibility is taking out the data from the request object, depending on what kind of request it is. If it is a get request, you have to take out the query params. That if it is a post request, you have to take out the request body. Similarly, for delete, we can take out the request body, and for put or patch, we can also take out the request body. Depending on what kind of request that is, we can take out the request body. That is the first responsibility of a handler or a controller. Now, we've already talked about serialization and deserialization, and there is a reason we are following this order. We are trying to trace the flow of the request from top to bottom, right? The request started from the client, and that's why the first thing that we covered was how HTTP lifecycle works, right? Then we went into routing, then we went to serialization and deserialization, then validation and transformations, etc., right? We are following the request from the top until it reaches our repository or our database layer. Okay, we already know that we have to do some kind of serialization and deserialization at this point, because the request, the client sends a request, and that request is serialized into a JSON format because it has to travel over the internet, and JSON is a serializable format that is used across front-end and back-end boundaries. And there are other serialization formats, but JSON is the most popular one as of now. Okay. Now, the first thing that we have to do in the controller layer, depending on your programming languages, the implementations might be different, but this is a common pattern. The first thing that you have to do is deserialize the JSON object that you received from the request into your native data format. Now, if it is a Node.js backend, then you might not necessarily do this step. There will be a middleware somewhere upstream before the routing happens, which deserializes all the JSON into JavaScript objects, right? That's why we have JSON.body parser, etc., middlewares in our Node.js apps. So that's why we don't necessarily do this step at the handler layer. But in other programming languages like Go or Python, we have to do this step explicitly. We have to deserialize whatever JSON that we receive in the request into our native format. So if it's a Go app, we have to deserialize into a native struct. If it is a Python app, we have to deserialize into a dictionary or a class. And similarly for Rust, we can deserialize into a struct, etc., right? We have to take the JSON data and convert into a format that we can understand, that our programming language can understand, that it has to follow its native data format. That's the first thing that the handler does. Takes out the data from the request object and it deserializes into the native format of the programming language that you are using. That is the first step. Okay. This is also called binding, depending on what framework that you are using. But most of the frameworks use this terminology, which is called binding the request body into your native format. And at this step, if the deserialization fails or some error occurs, then we send a request. We send a response to the client with the status code of 400, which says bad request. Use the error code of 400 to tell the client that this request is not valid. Something is wrong with this request payload, right? We send the 400 request and we terminate the request at this point. We don't continue. We don't proceed ahead, right? First thing. Now, second thing. And again, I am talking about an ideal production grade backend pattern now. Okay. Depending on the implementation, you might not have a validation layer, but we have already talked about validation and transformation in a previous video. And the advice is you should validate everything that is coming inside your server from an external client, everything, starting from your path parameters to your request body to your request query parameters, etc., everything that you can validate and be as specific as possible while you're validating it. We have already covered these things in our validation transformation video. Now, that's the second thing that happens here. Once we have deserialized the data into a native format, now we understand the data. Our programming language can make sense of the data. It cannot make sense of the JSON data because that is a serializable format and not every programming language. JavaScript has a very good support for JSON because JSON is inspired by the JavaScript object and it has first class support for JSON. But when you come to other programming languages, you don't have as smooth integration with JSONs. You have to do a lot of manual processing, right? Now, at the second step, we do validations and transformations. We take the data that we have bound here to our native format. Let's say we are using Go programming language. Now we have a struct. If we are using Python, now we have a class or a dictionary which contains all the data that the client has sent, but in our own programming language format. The client is using JavaScript. It has sent using JSON, but now we have a struct in Go which contains the same data in a different representation, but with the same values. Now we take that data and we validate it. We make sure that all the data that the client has sent, it is in the expected format. All the mandatory values are sent, all the values that are sent are in the expected format. There is no malicious intent, there is no missing values, etc. Everything that we do in a validation pipeline. After we validate it, we also optionally do a transformation. What does transformation mean? Transformation is basically after we validate the data that has come from the client, we do some kind of modifications to make it convenient for our server to process the data. For example, we can set defaults. Let's say we have a get API. We have a get API where we are fetching all the books. And there is a query parameter the client can send, which is sort. And in the value can be name or by date, the created date of that book, right? These are the values that the client can send. And the requirement is, and this is a good pattern that you should establish in your backend apps, that query parameters, you should try your best to do all the query parameters optional, right? That should be your requirement. That is a good pattern to establish early in your API design. And we'll cover all about API designs, all the best practices, RESTful architecture and everything in the next video. That is all about API designs and principles and how to think about APIs, how to design them, etc., etc. So there you'll have all your doubts cleared about this, how to structure this, how to start about this. But just a info for the sake of this video, that you should try to make all your query parameters in your APIs optional. And coming back to transformation, let's say this is the requirement. The client can send two values in the sort query parameter, either name or date. And if the client sends name, you have to sort all the books by the name of the books. Or if it sends date, then you have to sort by the date of the book, at what date that book was created. Now, in the transformation pipeline, let's say this request went through the validation and client did not send any query parameters. It just sent /books. There is the URL. It did not send any query parameters. In the validation pipeline, it goes through because you have made all the query parameters optional as a good pattern. So the validation pipeline succeeds. You don't get any errors. You don't send any 400 bad request errors to your client. It goes through. Now it reaches your transformation pipeline. Now you want to make it convenient for your database layer to process the data. And that is the reason in the transformation pipeline, what you can do, if the client has not sent any query parameters, you can set defaults. You can set defaults here, which means in the transformation pipeline, what you will do, you will check if there are no query parameters passed, you set the value of sort as date, or depending on the requirements, you can also set it to name. That's why we use transformation pipeline, so that we can do a couple of operations on the data that we have received from the client before it goes to the database layer or before it goes to the service layer, so that we can make it more intuitive and more convenient for our downstream layers to process the data in a more expected way. Let's say we did not pass anything, then the service layer has to check if the sort field is passed or not. If it not passed, then do this. If it is passed, then do this. Then we have a condition branch there. So it's a lot of inconvenience, but still doing this makes your code a lot more readable. It makes your code follow an expected path of processing. That's why we have validation and transformation pipeline. We won't go too deep into this. We have already covered this in the previous video. That's the second thing your handler does. Now you have taken out the request object, the request information from the request object. Then we have validated the data. You have transformed the data according to your convenience. Now you have a solid data format that is ready to get processed. That is ready to get processed by your downstream layers. Now, at this point, what happens? The controller layer calls the service layer with all the data that it has properly validated and transformed. It passes that data to the service layer and all the information that the service layer might need to process that data. For example, the authentication information like user ID, the user permissions, etc., etc. It passes all those data, and then the service layer starts processing. Now, what happens in the service layer? Now, the service layer ideally should not deal with any kind of HTTP related stuff. We try to limit all the HTTP related stuff in the controller layer for good reasons that we'll explore a little bit later. Now, the service layer is just a function. You can think of service layer just a function that has nothing to do with any kind of backend front-end interaction or such. If you take a look at your service method, then from one look, you should not be able to tell that this is a function that is being used in an API. That is a good pattern to follow. Your service layer should be in an isolated manner, should be doing all the processing and then returning the data. It should take some data, process it and return some data without worrying about post response code to return to the client, what kind of data it is receiving, should the validation, etc., etc. You should not have to worry about all those stuff. That is the responsibility of the handler layer. That's where we draw the line, the responsibility line. Okay. Now what happens in the service layer? It takes all the data that is needed to process, that is needed to do all the operations that we want to do. Then what it does, it calls the repository method for your database operations if that is needed. There are of course service methods. For example, if this service is only supposed to send an email to some client or to some user, then what it does in the data, it might be receiving the email address, and it takes that email address, it executes the logic which sends the email to the client, and it then returns a response that looks something like this: success is true to your handler back. It can also do something like this without calling the repository method. We also have services like this, or if it needs to deal with databases, whether it needs to persist some data or whether it needs to fetch some data from the database, then it uses the repository layer for that kind of information. Now, at this point, what happens? We have the repository layer or the database layer, depending on what terminology that you and your team is using. The layer again takes the data, whatever data that needs to be inserted or whatever data that needs to be fetched. Now all the requirements of the data. For example, we received the parameter sort from upstream from our handler, which either has a value name or has a value date. It takes the data, service layer takes the data from the handler and it passes the data to the repository layer, and the repository layer takes the data and it constructs the database query. The sole responsibility of repository layer is it takes whatever the data that has to be inserted, or it takes all the filtering data, the sorting data, whatever data that is needed to fetch data from the database, takes all the data, it constructs the database query, and it returns whatever the result that was returned by the database. It has a single responsibility. Takes some data, performs a database operation, returns it. Again, the requirement is one repository method should only return one kind of data, which means, let's say you have two repository methods, one for getting all books and one for getting a single book. Then ideally you should not pass an optional parameter in the same function, and depending on the optional parameter, you should not return a single book or you should not return all books. You should not do that. Repository methods have a single responsibility. If that repository method needs to return all books, then it should return all books. And if it needs to return a single book, then it needs to take the ID of that book and it needs to return the single book. That's how you should design your repository methods, so that the service layer, we have the service layer here. The service layer also has the responsibility to orchestrate, which means it can take the different data that is returned by the different repository methods, and it can like merge those data, take the necessary fields for different results, and it can return that data to the handler. Okay, that's the responsibility of the service layer. A service layer can use multiple repository methods. It can do different operations to merge different types of data from the database and etc. etc. A service layer can do a lot of things inside this, a one service method. But a repository method should do a single thing, is fetch some data depending on the requirements, or insert some data depending on the requirement, or delete some data depending on the requirement. Okay, and service layer orchestrates different repository method, or it does external API calling, it sends notification, it sends like an email to your user, etc. etc. It does everything that an API needs to do. All the actual processing of the API happens in the service layer. Handlers deal with data formats, the input data formats, the output data formats. The actual processing happens in the service layer. All the database calls happens in the repository layer. That's how we isolate the three layers. Okay, now the service layer called the repository layer for fetching all the books depending on the sort parameter. It got the response from the repository layer and it returned that response to our handler or to our controller. And we are back from the service layer. The controller layer called the service layer and it returned the data. The service layer returned the data, and now we are back at the controller layer. Okay, now what all happened? One, we did the binding of the data from the request in the controller layer. We did validations and transformations. Okay. Third thing, what it did, call service layer, which did the actual processing of the data. Fourth, we got the data. What the next thing to do? Send response to the client. So as you can see, the controller layer actually controls the data flow from client to server, from server to client. It got the data, it did some validation transformation, processed the data, and now it will send the response, an appropriate response back to our user, back to the client. And depending on the success or failure of the service method, whether we were able to process the data or not, the controller layer decides on a appropriate response code. It can be 200 codes, it can be 200, 201, 204, depending on the success. It can be any of the 200 series codes, or if there was a failure, then it can also be 400. If it is a client failure, it will be 400. If it is a server failure, it can also be 500. And it is the responsibility of the controller layer to decide an appropriate response code and send an appropriate error message if it is an error, or send an appropriate success message with the success data. In this case, it will return all the books, an array of books with a response code of 200, because it was successfully able to fetch all the books, and then it will send the data back to the client. That's how the request lifecycle looks for a single API call. And that's how handlers / controllers, services, and repositories integrate or cooperate with each other to process data from a client and send an appropriate response back. That's how cut. Next up, we have middlewares in the same context. Now, where do middlewares come in this whole picture of a request lifecycle? Now, let's do the whole request lifecycle again, but this time we'll use middlewares and we'll understand how middlewares work and where do they actually come in. Okay, we have a client. Let's not imagine client now. Let's say we get the request from a client. Now, the moment we get a request, the moment the request reaches our entry point, the moment our operating system forwards our request to the entry point, our server, from that moment on, we can have different functions in between. Like, let's imagine these are breakpoints, these are boundaries of different functions, and we can have this function. Then somewhere we can have our route matching stuff, where we forward a particular API call depending on which route it wants to go. We can have routing here. Then again, after routing, we can also have middlewares here, right? These are just different boundaries here. Then we'll have our handler, service, repository access. Then after this also, we can have middlewares here until the response is sent back to the client. Now, let's imagine what's happening here. What are these boundaries? Okay, we have these boundaries. We are already familiar about this part. We are doing routing here, and this part we just saw, that the handler takes the request, it takes out the unnecessary data, it does validation and transformation, it calls the service layer does the processing by using the repository layer for database operations, then it sends the response back, then the handler sends the response back to the client. We already understood this part and this part. Now, what are these things? What are these functions that are coming in between? We call these functions as middlewares, and from the name you can take some meaning out of it, that these functions are supposed to be executed somewhere in the middle. Somewhere in the middle of what? In the middle of these things, in the middle of routing, in the middle of handler services and repositories, and in the middle of sending the response back to the client. These functions are executed in the middle boundaries of different execution environments or different execution contexts. That's why they are called middlewares. Now, why do we use them? What do they actually do? Middlewares also like normal handlers, that we have already discussed, that typically a handler receives two things: a request and a response by default in its parameters, which is provided by our programming language or our framework or our library, whatever that we are using to build our server. These two objects, request object and the response object, that is provided to the handler by default by the runtime environment. In case of middlewares also, since these are also one kind of handlers, but with a one additional capability. These also get a request, these also get a response object, but these also get another thing called next. Next is a function, and we'll come back to next soon. These are the three things a typical middleware gets by default from the runtime, from the language runtime. It gets three things: one the request object, one the response object to modifying the response and stuff, and one is the next function. And the use of next function is, we have these boundaries that we saw, that there can be one middleware, there can be another middleware, and then there is the routing, then there is the multiple middlewares here, or there cannot be a middleware. From the routing, we can straight up go to handler, right? We can also skip these middlewares. All the middlewares are optional. That's something you have to keep in mind. Middlewares are optional functions that, depending on your requirement, that you can implement, that you can execute. These things may be there and they may not be there, okay, depending on your requirement. Middlewares receive three objects, which are request, response, and next. Next is a function which is basically passes the execution from one middleware to the next middleware. To cross this boundary from one middleware to next middleware, the runtime gives us one function called next. And as the name sounds, we are just proceeding to the next middleware or the next execution function. We cannot always say the next middleware, because if we focus on this execution, this is going from one middleware to our routing. Or if we focus on here, this is going from one middleware to our handler. That's why next function passes the execution to the next context. Whatever context next is supposed to process the request or is supposed to process the response, next function calls that. Okay. That's the use of next function. It just passes the execution to the next processing context. That's all about next. Okay. Now, since a middleware receives a request object and a response object, you can already imagine that a middleware can take out values from your request and it can send a response back to the client from this point only. The request may not reach our routing part. The request may not reach up to the routing algorithm, and it may not reach up to the handlers, which is far ahead in the request lifecycle. This middleware can do some logic and it can send a response back to the client from this point on. So, okay, because it receives a response object from the runtime. That is the capability of a middleware. It can take values out from request, it can modify the values of the request, and it can also send back a response to the client. That's the capabilities of a middleware. Now, why do we use middlewares? Okay, why not do everything in the handlers only? Why do we use different things? Now, the obvious answer is because the same reason we use functions. Why do we use functions? So that we don't have to write the same set of lines of execution all the time in different places. We can just write those few lines in one function. We can pack that in one environment. Then we can call that function again and again in different places. Depending on our requirement, you can pass different parameter to it and change the order of the execution or the result of the execution. But we can reuse that code in different places. That's the reason we use functions in programming. Same way we use middleware so that we can do some logic in our whole API request lifecycle again and again in different requests. So as a backend application, your app receives thousands, or depending on the scale, depending on the popularity of your platform, it might be receiving thousands and millions and billions of requests every day. And because of that, you have to do some kind of common operations. You have to do some kind of security operations, logging operations, and authentication operations, and data parsing operations for all those requests. Now, You also, as a huge backend application, you also have hundreds and sometimes thousands of API endpoints. Now, for each API endpoint, you will have handlers. There is no way avoiding that. You have to write different handlers for different API endpoints. That is there. Now, if we don't have middlewares, we have to perform the same set of operations for each handler. We have to duplicate that code for each handler. And at this point, you might also say that we can write a function and we can call that function in every handler. You can do that, but that is still some kind of duplication, that you have to call that function in every handler. That is the reason, to minimize that code duplication, to minimize that redundancy, we delegate the responsibility of dealing with some common operations, whether it is security, whether it is logging, whether it is data passing, whether it is compression, all these different common operations, we delegate those parts to a different component of our request lifecycle, and we call that middleware functions. Middleware functions because they will be placed in the middle before it reaches the appropriate component, before it reaches the handler, and they will do these common operations, and depending on the result of those operations, they can even send a response back to the client before that request reaches our handlers, so that we don't waste our precious server resources. That's why I use middlewares. Number one requirement being to reduce code duplication. Now, the second thing to keep in mind is the order of middleware is important. This order is important because as a request from our client reaches here at the entry point, and starting from this, every middleware using next function passes the execution to the next middleware. Okay, it passes this to the next middleware, then it passes to routing, then routing passes the execution to the next middleware, then until a response is sent back to the client. This all happens using the next. The middleware can use next function to pass the execution to the next middleware, if there is one. This order of passing the execution to all the different middlewares is important. That's how our request will be processed. The order is important. Now, these are some examples where we use middlewares typically in a backend application for, let's say, security purpose. Security purpose can be, let's say we have different middlewares. Let's say we have CORS, then we have security headers to add security headers. Then we have authentication middleware. Then we have rate limits. Let's see what each of these middlewares do. Then we'll understand why they are a middleware instead of a common function. We have already understood CORS. CORS is basically a security mechanism, a privacy mechanism followed by the browsers, which states that your application that is running in the browser cannot access resources outside of your own origin, which means if you have domain example.com, then you can only access resources from example.com. That is a restriction browser poses on you as a client. Now, to bypass that, not bypass necessarily, but if the remote resource sends a header, the remote resource sends an appropriate header which says that your client is allowed to access the resources from this server. In that case, the browser won't block the response, won't block that request. That's why we have CORS, so that we can limit what kind of clients, at least web apps, can communicate with our servers. Okay. Now, on the server side, what happens is your server gets the request from the client and it has to check the origin of the request, where it is coming from. That is automatically given to us by our runtime. We receive an origin value from where the request is coming from. And depending on the origin value and depending on what are the origins that we are allowing to communicate with us, we can set some headers. If it is an allowed origin, that is, if it is the front-end domain, that is our front-end platform that is trying to communicate with our back-end platform. If that condition is true, if it is our front-end platform, in that case, we want to add the appropriate headers. We have covered this whole workflow in our HTTP video in the backend from first principles playlist that you can watch to understand how the whole CORS flow works. We don't want to go too deep into this since it is about a different topic. Now, we want to add this particular headers that will tell the browsers that it is allowed. This request should be allowed in the same origin policy. Now, we want that to happen if the origin matches our front-end origin. Okay, if that condition passes through, we want to add those headers, and then we want to pass that on to the next middleware. As we have already seen here, each middleware does something and passes that request to the next middleware, or it can send a response back to the client. At this point, in the cores middleware, what happens? It gets the request, it takes out the origin, it checks if it is our front-end domain. If it is our front-end domain, it adds some headers to our response object. It adds some response headers that this is the allowed origins and etc. etc. Then it passes that to the next execution environment or the next middleware. Okay, if it does not match, then we don't add any headers, and the browser will block the request by default when we send the response back to the client. Okay, now the question is, why did we make this as a middleware? Because this is a function that needs to happen, that needs to get executed for each API call that our server will receive. That is the first requirement. We want to reduce the code duplication. It needs to deal with the request object or the response object. In this case, it deals with both. It takes the origin out of the request, it modifies the response headers. That is the second requirement. There is some code that needs to run for each request, and it needs to deal with the request and response object. That's why we made this a middleware, so that we don't have to do this for each handler. Okay, this is the perfect requirement for a middleware. That's why cores is usually implemented in the middleware layer, not in the handler layer. Okay, similarly, we have security headers. From the server, we can set different security headers, for example, content security policy, etc. etc. And we want to set that for each API call that we receive. That's why we also made this a middleware. It gets the request, it adds the appropriate security headers, and it forwards that to the next middleware. Similarly, we have authentication. We make authentication as a middleware because we don't want to duplicate the function of getting the token. Usually when we authenticate, we take the token. If you have seen the authentication and authorization video in the backend from first principles playlist, then you will understand this. Usually in authentication, we take some kind of token. It can be JWT, it can be session ID, etc. from the request object, and from the headers or from the payload or whatever your implementation is. We do some kind of logic to verify whether it is proper credentials or not, whether it is a proper token or not. Depending on the success or failure of that, if it was a failure, then we send a 401 unauthorized error code to the client right from here without going to our handler layers, without forwarding the request to the next middleware. We immediately send an error code back to the client and we terminate the request right there. Or if it was a success, what we do, we authenticate, we take out whatever details is needed. For example, the user ID or the permission or the role of the user, whether the user is admin or not, etc. etc. We take this, we add this to our request context, and that's the reason the request context is our next topic of discussion. We add this information to our request context and we forward it to our next middleware. We don't send a response back to the client immediately. That we do only in case of failures. That's the reason we make authentication as a middleware, so that for each request it verifies the credentials or the token, and accordingly it terminates the execution or it passes the execution with the appropriate metadata like user ID and user role to the next middleware. Similarly, rate limits. Rate limits we implement so that one client cannot do a lot of requests in a short amount of time. We pre-decide a reasonable number of requests that a client can send in a particular period, and we add a middleware which checks that. We do that with IP addresses. We check that whether this IP address has made more than 30 API calls in the last 2 seconds. Something like that. We decide the threshold ourselves. We decide the thresholds of the time and what time period you want to check. We also decide the threshold of the API calls, whether it is 30 API calls, whether it is 500 API calls, etc. etc. And according to that, we implement our rate limit. If the client exceeds the limit, what to do? We send an error code of 429, which basically we send when there are too many requests from the client. we send an error code of 429 back to the client saying there are too many requests in this short period of time. If the client has not exceeded the limits, then we pass the execution to the next middleware using the next function. Okay, that's some of the examples of the security middlewares. Similarly, we have logging middlewares and monitoring logging middlewares, logging and monitoring middlewares, which basically every time we get an HTTP request, let's say we got a GET request, okay, we can do some kind of logging in our server, in our terminal, or whether a log file, so that we can later on, it helps us debug information, it helps us in reports, etc., to track different parameters. For each request, this middleware gets different parameters out of that request. For example, what is the path we are trying to access, which is users? What is the request method, which is get? What are the query parameters? What is the request body, etc. We can log a lot of information for each request so that it's easier to debug and it's easier to audit, and etc. Okay, that is the example of logging middleware. We also have global error handling, and this is very important. You feel every backend application should have some kind of global error handling, so that what happens, it does not matter at what point some error occurs in your application. It can happen in the handler layer, it can happen in the service layer, or it can happen in any of the middlewares that are executing in between different function boundaries. In all these different execution environments, does not matter at what point an error occurs, this middleware can get that error. It will get that error, that generic error, whatever happened. And from that, what it can do, it can find out whether this is a client error or not. We can define different parameters or different fields inside the errors to indicate whether this error was a client error or this was a server error. Something went wrong in our server execution. Depending on that, it can send a 400 errors or 500 errors, and it can send a properly structured error message, which usually has a message or some kind of code, so that the front end can render different user-friendly messages depending on the code or the ID, sometimes also called ID, and the status, back to our client. So the goal of the global error handling middleware is it takes out an unstructured error from anywhere from our app, and since it is a middleware, it has access to that. And because of the nature of global error handling middleware, usually what we do in our middleware lifecycle, we have different middlewares at different points, right? It is the entry point, this is the first middleware that happens, and this is the last middleware. Usually what happens, we keep the error handling middleware at the last. We send a response back to our client, because in all these different executions, error might happen in any of these cases. So that last middleware can get that. It can check whether some error occurred. If it did, then it can properly structure that error and send a properly structured error message back to the client. That's the reason we use global error handling middleware at the last point of our execution as the last middleware. And as I said, the ordering of middleware is important, because if you use error middleware somewhere in the middle, then if some error happens in our handler at this point, then the error middleware won't have access to that error, because the execution of that middleware was happening here, but our error occurred somewhere in the here, and the request flows this way. Okay, it flows one way. We cannot get the error back here. That's the reason we should think more about how we are ordering our middlewares. Now coming back, we similarly have compression middleware, so that if you have a large response, let's say we have a JSON which has thousands and thousands of fields, we can use some kind of compression algorithm like gzip, etc., to compress that response and send the response back. Typically, modern browsers have the capability to decompress that response back to a format that browsers can understand, that clients can understand, so that during the transit, a compressed format is in use, but during the client deserialization process, that compressed format is again converted into a proper client format, for example, a JavaScript object, etc., right? We also use middlewares in case of compression, etc. Similarly, for data parsing, the process of serialization and deserialization, we can also delegate that to a middleware, so that we don't have to do that in different handlers. Of course, that depends on the requirement of your backend, on your code base, and what are the standards that you use, what are the styling standards that you are using. But you can also do that. You can delegate the validation transformation into a different middleware, data parsing, the binding of data, the serialization and deserialization data to a different middleware. So these are all the examples of how middlewares work. And as I said, the ordering of middleware is important. That's the reason typically in our request lifecycle, the first middleware that gets executed is CORS. Because if it is coming from an origin that is not supposed to have access to your server, in that case, you want to find out that information at the early stage of your request so that you can terminate the request right here. That's the reason CORS is executed the early phase. Then we usually execute some kind of logging middleware. Then we have authentication. Then at the end, we have global error handling. As I said, the ordering of middleware is important depending on how you're structuring your application and what are your requirements. You should spend some time in thinking at what order these requests has to be modified, or at what order the request lifecycle should follow to provide a appropriate experience to the client which is making the API call. And that's pretty much all about middlewares. Now, somewhere at this point, we talked about the authentication middleware and how it stores some kind of information like the user ID and the user role in some kind of storage, and it passes that to the next middleware or to the next handler. Okay. And that part is called a request context. Request context is also something that you will see in a lot of backend applications. Does not whether we are using Node.js or Golang or Python, etc., etc. Every framework, every language, every library provides some kind of request context implementation. Request context can be an abstract concept, but it is also a concrete implementation. The implementation logic might vary depending on what language or environment that you're using, but this concept kind of remains the same across different languages. So what is this concept exactly? Request concept is basically some kind of storage or some kind of state that is scoped for a particular request, that is limited to a particular request. So each request, so let's say you have a server, you have a client across the world, you have hundreds and thousands of clients, and each of them send different requests, hundreds and thousands of requests for each client. Each of these API calls, each of this request will have a context attached to them depending on the implementation of your HTTP server. Okay, each of them will have some kind of context. And why do we have this context? So that we can have some kind of storage or some kind of state attached, which is accessible across our middleware and handler boundary. So as we saw somewhere early here, when the request reaches here and until the response is sent back to the client, there are different function boundaries. Usually we have different middlewares that are processing here. There's a CORS middleware, there's a logging middleware, then we have routing, then we have authentication middleware, then we have some kind of middleware that is limited to the application. Okay, some kind of permission checks. Then we have our handler logic. Then at the end we have global error handling middleware, etc. Until response is sent back to the client. We have different middlewares. Now a context is typically some kind of storage, usually a key value pair. We store some kind of key value pairs inside the context so that this information is accessible by all these different execution environments. It is accessible in all these middlewares. Now this middleware can set some value in this context. Now this value will be accessible to this middleware at this point without explicitly passing those values directly, without coupling the system together too closely. That's the reason we have some kind of state which is accessible by all these middlewares and all these handlers. All of them receive this context. This context, or also called as a state, which is limited to this request and is accessible by all the execution environments, all the middlewares, all the handlers, etc. Okay, so that our system is not closely coupled. We have this state is accessible by all of them, which is modifiable by all of them. Some kind of storage for the sake of convenience. So in this example, what we did in the authentication middleware, We verified the credentials of the user if it was a login attempt. It was the first time the user was logging in. We verified the credentials, the email and the password. And if it was successful, we created a user. If it was an already existing user, we took out the user ID, and we also took out the role. The role can be user or admin or sales, any role, right? Depending on your RBAC implementation. We have already discussed RBAC in our authentication and authorization video. So from there, you can understand what are roles and why do we use them, and also about different authentication methods. Okay, so we have some kind of authentication mechanism, and using which, after the authentication is successful, we have different information. We have the ID of the user for our platform. We have the role of the user, whether it is a user, whether it is an admin, etc. We have a sales, or different permissions, whether the user has read permission for this resource, whether it is a write permission, etc. All this metadata about the request, and it is only limited to this request, this particular HTTP request. Now, this will be stored in the context, so that, let's say, your authentication middleware set these values inside the context. So later on, downstream, your handlers, which is going to insert. So it is a API which is a post API to the /books endpoint. So what your handler can do, somewhere upstream, your authentication middleware verified the credentials of the user, verified the token of the user, and it found out these information, and it saved those information in the request context. Now what happens in the handler, when the execution reaches your handler, the handler can take out this information, the user ID, the user role, etc. And what it can do, it want to insert a book. It want to insert a book into the database. So a book table might have a field called user ID. So instead of taking the value of user ID from the client, from the user payload, instead of doing that, what we do, we take the user ID from the authentication information. From the result of the successful authentication, we can take out who is the user that is making this API call. And that's how we take the user ID and we insert that into the database. And why do we do this? Because if we take the user ID from the client, a client with a malicious intent, can send the user ID of some other user to do unexpected operations in our server. That's the reason when we want to access the user ID, when we want to store, or when we want to check different user related information, we take that information out of the authentication middleware. We save that into a context, and in the downstream methods, in the handlers and in the next middlewares, we take that user ID and we perform different permission checks in the database layer or in different RBAC layers, depending on that information, whether the user has permission to insert a book or not. We can take that from this, if the user is an user, if the user is an admin, etc. So all in all, a context is just a shared state that is accessible to all the middlewares and handlers, so that our system is not closely coupled and we have some kind of state, some kind of storage that is limited to one request. Similarly, we can use the request context to store the request ID. So initially, somewhere upstream, we can have a middleware, which, let's say somewhere here, we have a middleware somewhere here where we generate a unique ID, let's say a UUID. We generate a UUID and save that in the context. So throughout the execution of this request lifecycle, we use this particular ID, we take that out from our context and we use that in different information. We can log the ID here and we can use the ID to make API calls to different services. Let's say it's a microservice architecture. So we can take that ID and we can call that API with this ID in somewhere in the header, let's say X request ID or something like that, so that when we are auditing our logs or when we are reviewing our logs, when we are debugging something, we can trace the request, where it started from, which service it started from, of all the services that it called, etc., right? And we can do that because we have a shared state which is called request context, where we can save information for that request. Okay, that is another example of when we use request context. Request context we also use to send cancellation signals and abort signals and deadlines to our downstream external services so that our service does not hang up perpetually. These are all the use cases of request context that we typically have in a backend server. So that's all about handlers, services, repositories, middlewares, and request context.